Hello everyone. So I'm just going to do a live stream on an interesting system that has appeared in the Mediterranean. I'm doing a live stream because I don't really want to make a video because it'll take too long, and this is something I want to do on the fly. So this is I've got here the some satellite imagery. This is from sat24.com. So actually I've got this on. Okay, this is on infrared at the moment, but I'll put it on visible so you can see the visible satellite. Sorry about this. That's the UK. There we go. Okay, that's this. This is the visible satellite. Now, so what we have here is technology never works, does it? So what we have here is something that I think could stay. So what we have here is what I think could very well be an example of a tropical storm forming in the Mediterranean. This might seem quite absurd, but it's actually not as rare as you think, and it does happen. These systems are actually nicknamed Medicanes, sort of an amalgam of Mediterranean and hurricane. And there's actually a very interesting Wikipedia article about Medicanes, and you can see some pictures of them. They do look like tropical storms. So this one in particular is quite impressive in the way it looks. And it's the saying, if it looks like a hurricane, it is one. Just a bit of background. A hurricane is a type of strong tropical cyclone. A tropical cyclone is the generic term. The weakest form of tropical cyclone is a tropical depression. Then you have the tropical storm. And then when you get above 74 mile per hour sustained winds, you begin to get into the category 1, 2, 3, 4, 5 hurricanes. What makes a tropical cyclone special as opposed to a mid-latitude depression, which the UK gets a lot? I mean, things like gale force winds are not unusual in the UK, but what makes a tropical cyclone special is the sort of mechanism which it forms. It's a system that is convectively based, so the heat of the oceans contrasted with the very cold air in the upper atmosphere is what fuels these systems, as opposed to the mid-latitude depressions, which are in a sense frontally based. They're based on different air masses colliding with each other. Tropical cyclones are not based on that. They're based on convective processes. Now, essentially, there's three basic ingredients that you need for a tropical cyclone. The most popularized one is warm sea surface temperatures, because you need to get that contrast between the warm surface and the upper atmosphere, and it's got to be over the sea, of course, because the moisture you need the moisture to be able to fuel the convection. So you've got to have warm sea surface temperatures, typically above about 26 degrees, to usually get a tropical cyclone. That's the first condition. The second condition, this one is actually even more important than the first condition, is you need an environment that has low wind shear. So wind shear is that when you go up in the atmosphere, the wind can change direction and it can also change speed. And this is very, very bad for tropical cyclones when you have a strong wind shear, because it tends to, in a sense, blow the top off them. And it destroys them fairly quickly. So you don't want that. The third criteria is you need the Coriolis force, which is a fictional force based on the Earth's rotation, which is weak at the equator and stronger the further away, further towards the poles that you get. It's the thing that causes these cyclones to rotate, and it's extremely important to have the Coriolis force. So this is why you don't get tropical cyclones on the equator. So the Coriolis force is granted. If we look at the other two conditions, sea surface temperatures, Mediterranean is typically not warm enough for cyclones. It's borderline, so it's probably 22, 24 degrees rather than 26. Although after a very warm summer in Europe, temperature is actually very warm for the time of year, 26, 27. Wind shear is, of course, the big one. And unfortunately, fortunately, high latitudes have very strong wind shear, which means that it's very unusual to get these systems to form. Now, since the Mediterranean is a borderline area, you do get these things forming sometimes. Though that being said, and I think this is an example of a situation when one is forming. These tend to form, I think, a couple of times a year, but there's no agency that monitors them, like the Atlantic, for example, the North Atlantic, that is. I think there's can be parallels drawn between the Mediterranean and the South Atlantic, because the South Atlantic wasn't monitored either up until a few years ago, after Cyclone Katrina hit Brazil, which was thought to be an extremely unusual event, and it was unprecedented because tropical cyclones are so rare in the South Atlantic, chiefly due to very high wind shear. The environment is kind of similar, although the Mediterranean is shallower, which doesn't exactly help. That being said, the sort of if you look at this storm, just by looking at it, you can tell that it's unusual. You can see these pockets of convection. These are thunderstorms, individual thunderstorms, and essentially these tropical cyclones are made of thunderstorms. Let's compare it to well, actually, you can't really see much on this satellite, but you can see if you're looking at the sort of thing that you're getting in the Atlantic, it doesn't look anything like it. This is a convective based system, and if we take it through. Personally, I think that if this system was in the Atlantic rather than the unwatched Mediterranean, it would already be classified as a tropical system, or at the very least a subtropical system, a sort of hybrid system between the mid-latitude depression, the mundane of the high latitudes, and the mundane of the tropical latitudes, the tropical cyclones. And you can see again pulses of convection here. Have I got this on infrared? I think I might. Okay, I think I've got this on infrared. Infrared, yeah, this is on infrared rather than visible. It doesn't really matter, because it'll still look roughly the same. The way infrared works is that it looks at the temperature of the cloud tops. So these brighter colours, the brighter whites, basically means colder cloud tops. The colder the cloud top, the bigger the cloud. So you want really cold clouds, because that implies a lot of convection. There's no eye yet. This system does not have an eye wall or an eye. I think one will develop. So I'm going to have a look at the. By the way, this is all. This is just sort of my suspicions. I'm not an expert on tropical cyclones. So if anyone has any information about this and would care to weigh in, it would be really interesting to me personally. Whether this thing could develop into a hurricane, I think it could, but I'm by no means an expert. So. Hurricane maybe is the wrong word for it, because again, for hurricane you need 74 mile per hour winds. I suspect the winds will be not 74 miles an hour, probably tropical tropical storm strength winds. Let's have a look at some of the models then. So this website is so what I've got here is, and thanks to the Weather Outlook for guiding me to this website. It's really interesting. This is a cyclone phase map. So again, this is just an example. I think that this one is actually showing. I don't know whether this is showing. This is just an example of a particular storm, but essentially you have these 4 different areas, and mid-latitude depressions are in this blue region. They're very anti-symmetric, very asymmetric, so that they're very frontally based. The average mid-latitude depression has 3 fronts: a cold front, a warm front, and an occluded front. They're very, very, very asymmetrical, not circular at all, highly elliptical, and they're based on the collision of air masses. So this is a standard mid-latitude depression. In the red area here, we have a standard tropical system, highly symmetric, so circular. And a warm core, so there's warm air in its center. This is in contrast to the mid-latitude depression, which is colder than its surroundings. A mid-latitude depression has a warm sector. That's the area between the oncoming cold front, which brings colder air, and the oncoming warm front, which brings warmer air. So in between the warm and the cold front, you get this bank of warm air that these depressions have. The actual center of this depression a mid-latitude depression tends to be cold, and it tends to have this warm sector, compared to a tropical cyclone, which doesn't have a warm sector. It actually has a warm center versus sector. It has a warm center, and the pink and the grey area is sort of hybrid system. So I guess Hurricane Sandy, which was a more hybrid type system, so it had characteristics of both the mid-latitude depression and the tropical cyclone. Of course, it was originally a hurricane, but when it hit the US, it was a hybrid type system, will be in this grey or the pink area. So with that being said, let's look at some examples. This will be quite interesting. So I'm looking at the GFS here, which is one of the American models. So let's look at the GFS. So you can see all the black circles are all the different areas of low pressure all over the world. So I'm going to show you a few of these. Number 10 is a known hurricane. So number 10 is already a hurricane. So let's look at the profile of number 10. I know that this is definitely a hurricane. So you can see that we start off at C, which stands for current. You can see that it's in this warm region, and it's projected to sort of do this track. It's projected to go even more into the red zone, and then I guess as it moves north, it's sort of transitioning more towards the mid-latitude depression, as these things tend to do. So that's an example of a tropical cyclone, the profile of tropical cyclone. So that's the first one. 38. I'm going to use this one as an example of a mid-latitude depression, so one of these frontal type systems. So let's look at 38. What does that look like? Okay, so 38, it's in the blue area. You know, completely expected. Sorry, it has a cold core. So again, we're well into the blue area. It's a definite frontal system. So now the interesting part. Let's look at this thing, which I think might be tropically, has some tropical characteristics, which is number 50 here, the so-called Medicane. And you can see it's sort of in the middle. So it has some tropical characteristics. So actually, this is where we are now. So again, this is what we're looking at with the sort of, so I'll bring it forward. This is what we're sort of looking at with the current satellite now. So this is where we are now, kind of in between the blue and the pink region, more towards the blue, I suspect. And look at what the forecast is going to be. We're going to go well into the pink region, which is still asymmetric, but it does have a warm core. And I think having a warm core is more important than it being asymmetric. I ideally want to be in the red section. But it does get fairly close to the red, at least for a time. So this to me suggests that this system does have tropical characteristics. It might not be a perfect tropical cyclone, but it does have tropical characteristics. So what I'm also going to do is I'm just going to see if any of the other models agree. So that was just the GFS. Let's look at the Met Office's own model, the UK Met Office. Let's see what the Met Office says. Again, we can click on this little black circle here and see what they say. Oh, you see, this one's even more interesting. So we're actually projected to go right into this red area. I think Z is forecast. Actually, I might be reading this slightly wrongly. Yes, Z is definitely forecast. C is so A is where we started off. So over Africa, I guess, and C is where we are currently, and then Z is the projected track. And you can see that it's heading to this French island here. I can't remember what it's called. Call something or other. Sorry about that. But yeah, so C is where we are now, and you can see that we actually go into the red zone, which is indicative of a fully fledged tropical cyclone. That's very interesting to me. I'm not sure if it's worth looking at any of these other models. This is the Canadian one, incidentally, CMC, Canadian model. Let's have a look at what the Canadians think about this. Okay. So actually, the Canadian model says that we're already sort of in the red zone. So it already has tropical characteristics. And I was just sort of brought to the attention by looking at this satellite. To me, this does look seem to have tropical characteristics. So let's have a look at the sort of projection for this storm. What's going to happen with this? So I've got various models here. I'm going to start with the WRF if I can. Here we go. So this is meteosil.fr, a great French website with loads of different models on it, model visualizations. So this is the WRF model. I'm going to look at, if I may, the equipotential 850 temperature. This thing here, theta E. What this is, I quite like this because it's a sort of a measure of not just how warm the upper atmosphere. So this is at the 850 level, so it's like something like 3,000 feet. But this is a sort of a measure of not just how warm the atmosphere is, but also how moist. So don't really take these numbers. These numbers aren't temperatures. Obviously, it's not going to be 40 degrees at 3,000 feet. They're not temperatures. Specifically, this is the amount of the temperature that it would be if you could condense all the heat out of the moisture. But the actual numbers aren't important. The most important thing is the colors. Obviously, red is warmer and wetter, and green is cooler, so on. So this is a system that we have over the UK at the moment. You can tell it's got a cold core. The warm areas to the south, and there's also like frontal systems here that bring in. I think this would be a warm front bringing in warm air. So this is a classical sort of mid-latitude type depression. Now let's look at our friend in the Mediterranean. It's got a warm core. Now, to me, this is very interesting. Let's cycle through. So this is actually, this is 5 o'clock today. This is the model 5 o'clock today. Let's see what happens when we cycle through. So you can see. So keep watching this area here. So you can see that it's actually getting warmer and warmer. You can see that this purple color starting to appear now. And note that all the warm colors are not to the south like they would be in a depression or in like banks between fronts like they are in mid-latitude depressions. It's right in the middle. So you can see that. So what's this? So this is tomorrow at 2 o'clock in the morning. 2 o'clock in the morning, British time. Not British time, French time. So you can see that it continues to develop, and this to me looks very symmetrical. You can see that you get cooler as you move out further away from the center of the storm. It looks symmetrical to me. This definitely, to me, this looks like a classic tropical cyclone. And I think if it's hybrid now, something like the GFS or the Met Office model will be right. It's going to probably be more tropical based by tomorrow. So we can see it's actually going to hit this. It seems that it's actually going to hit this French island here, or is it part of Italy? I'm not too sure. Geography needs some testing, but you can see that it's fully warm cored by tomorrow afternoon. Fully warm cored here. You can see that some air masses are starting to go into it, so you can see that there's actually a little bit of a cooler region here and a warmer region here. That's starting to indicate that it's beginning to transition into a frontally based system. And you can see that as it moves over the land, it's going to quite quickly dissipate. So even by tomorrow evening, it's a pretty powerful system. But then as it moves over land, it'll very quickly disappear. So you can see, it very quickly transitions to a mid-latitude depression type feature, and then you can see this bank of warm air here, which is indicative of the mid-latitude depression rather than it being in the center. Satellite image of we can not satellite image. You can look at some 10-meter wind speeds. So some Medicanes don't tend to have really strong winds. This is not going to probably be a category. I think at the very worst it might be category 1, but I don't know. I'm not an expert, but I think that's highly unlikely. I think tropical storm type wind speeds between 39 and 74 sustained is far more likely. But I'm interested in looking at the profile to see if any sort of eye feature develops. I mean, you can also already see that there is sort of an eye with the low wind speeds right in the middle, but that's not really impressive because even mid-latitude depressions have lower wind speeds in the middle, like this thing, which is in mid-latitude. This thing even has weaker winds in the middle. It's not impressive because it's not symmetrical. It doesn't look like a cyclone, a tropical cyclone, because it doesn't really have that symmetrical profile. But let's go through and see if it becomes more symmetrical as it's projected to intensify. You can see the wind speeds do seem to be increasing. I mean, look, it seems that the actual eye type feature is becoming sort of more well defined, so you can point exactly to the center of this thing. Whereas look at these, there's like a band of white. They're not well defined. Whereas this thing is very well defined. You have almost like an eye wall starting to develop around the central feature. Where the strongest winds are just outside the center. It almost looks like an eye wall type feature, and you can see that again it seems to be becoming more symmetrical. I mean, the wind speeds are stronger on this sort of western flank. But then, of course, it is moving sort of more or less. It is moving in a southeasterly direction, so you would expect the winds on this side to be stronger anyway, just because of the addition of the cyclone velocity, not just its rotational. So you would expect the winds to be stronger on one side anyway. But to me, apart from that, this looks very symmetrical. So by sort of tomorrow morning, this looks like yeah, I would say if this was in the Atlantic, it would be definitely categorized tropical depression, tropical storm. So anyway, let's keep going. You can see it's actually going to impact this island. And incidentally, I guess there's a bit of a worry that if this does happen, there could be. I mean, I'm not expecting the wind speeds to be massive. Again, 74 mile an hour for a Category 1. I think that's very unlikely. So strong winds, possibly gale or severe gale, but I think that's maybe a little bit excessive. But there might be a storm surge, and of course there's going to be heavy rain and thunderstorms with this. And with the migrant crisis at the moment, it just seems like the worst possible time for a storm like this to develop. And I mean, these things are rare, and this looks like a really potentially strong one. Just from sort of looking at how it's going to develop. Anyway, as we go through, you can see that it's gradually becoming a little bit less symmetric. It's sort of elongating out from north to south. It looks a bit more elongated now. This is, again, you want it the sort of most the classic thing about tropical cyclones is they are symmetrical, and this is becoming slightly more elongated now, so you can tell it is starting to weaken. And when it goes over land, again, the eye seems to be becoming a little bit less defined, but when it hits the mainland, I know that the winds seem to be strengthening here, but I don't think that's really a feature of I don't think that's, I don't know. I'm not really sure, to be honest. But when it hits the mainland, it'll die almost instantly. Yeah, you can see that when it hits the mainland, it basically disappears. You can no longer easily define the center of circulation. But notice how different it is compared to these areas of circulation, which are just normal mid-latitude depressions. So let's have a look at precipitation. Precipitation. My GCSE French is coming in very handy here. I think radar basically means precipitation, so we'll look at that. It's in decibels, though, unfortunately. So yeah, you can see that there's an awful lot of moisture over here, and you can see that I'm just looking to see if as this develops, whether it's becoming more symmetrical or not. And so this is sort of 4 o'clock in the morning. Doesn't look quite as impressive, really. But you can see here, this looks like a sort of I-type feature, maybe. I don't know. A little bit more symmetric, perhaps, but it's got quite a north to south type elongation. So I don't know. It's still certainly going to drop a lot of rain, that's for sure. And as it hits the land, it'll fizzle out quite. Yeah, it's going to fizzle out almost immediately. Okay, let's have a look at another model. So I don't really know much about this model, actually. I know it's a new model. Where's wind speed? Does this one even show wind speed? I don't know. Precipitation. I wish I could understand French. I did actually do a GCSE in French a long time ago now. Here we go. So this is, I don't really know what this model is. It seems to have come online relatively recently. So let's just have a look through. Okay, so you can see it's right at the bottom here. It's unfortunately a little bit covered. Yeah, that's unfortunate, actually. So let's just go through and see whether this thing develops a little bit more. Oh, this is just off the map. It's unfortunate, that is. It's just off the map. Actually, can we zoom out a little bit? Oh yes, we can. We can get an Italian version of the map. Okay, sorry. Oh, damn it. It's okay. I think this will be better though. So anyway, let's have a look and see if we can get some sort of nice I-type feature developing. So yes, this definitely looks a lot more symmetrical than it did. Strongest winds on its western flank, but again, you have to take into account the fact that the cyclone is also moving, so that will add to it somewhat. On the whole, it's quite symmetrical. The eye is not a circle, so let's see if we can get a circular eye. Okay, there we go. There we go. When's that? When's that? When's that? That looks beautiful, really. When's that? That's 10 o'clock tomorrow morning. Oh, yeah. Okay. So, oh yeah, you see, look how well defined that is. You can point right to the center of this system. It looks so much like a tropical cyclone. I just it doesn't I don't know. I might be wrong about all this. I might be wrong about this, but it does not look to me like a mid-latitude depression. And in any case, at this time of year, what are we? We're in late September now, which is sort of a good 3/4 of the way through. I mean, we're getting to the point where the tropical, the hurricane season in the Atlantic is in full swing. Hurricane season at the moment, but it's not the season for the Atlantic to be that active. It's not as active as it usually is, and it's especially inactive at the moment. So having a depression in the Mediterranean at this time of year, given that we're not in October or November yet, is pretty unusual. In any case, and the fact that it doesn't even look like a mid-latitude depression says to me that this thing is tropical. I might be completely wrong about this, but it just, again, if it looks like a hurricane, it is a hurricane. I don't know, but look how well defined the eye is. Again, I mean, there's the sort of the strongest winds aren't right in the middle, but it's just so well defined. I mean, it's not the sort of thing you'd expect to see in a mid-latitude depression. But you can see as it hits land, it starts to. I know the wind speed seems to increase, but you can see that the sort of it becomes less well defined, which is exactly what you'd expect for a tropical system hitting land, but not necessarily what you'd expect for a mid-latitude depression, which tends to be hardier. And you can see as it hits lands, I mean, it tends to become less well defined. And when it hits the mainland, it'll I mean, it just fizzles completely when it hits the mainland. Does this one have precipitation? That might be quite interesting to see if this one has precipitations. Here we go. Okay, here we go. Let's see what happens here. Let's see if we can get a nice eye type feature on this one. So let's go. So it says this. I think it's going to be strongest at around sort of tomorrow morning is when it's going to be strongest. So maybe 9 or 10 o'clock. So this is 5, 6, 7. Trying to develop an eye. I'm not sure. 5, 6, 7, 8, 9, 10. I can tell it's trying. It's just not really succeeding. It seems to get pretty close. It's not quite as impressive, really. I don't know. Anyway. One thing I'm also probably going to finish off with is I said that the most important aspect of tropical cyclone development was wind shear. The sea surface temperatures are actually really warm, unusually warm for the time of year, so that helps. But let's look at wind shear. So I've got a map of deep level shear here, which I hope is the right thing to be looking at. I've just closed it. Sorry. Let's open it again. Sorry. Windows technologies, but anyway, so I've got a map of deep level shear here, and let's put it to 0 hours. So the sort of the pinks and the reds are heavy shear. So these sorts of colours would really damage a tropical cyclone. The blues are what we're looking for. We can get some blues over this sort of area. So when's this valid? Does it tell us when it's valid? Is it 6 o'clock in the morning on the 14th of January? Oh, that's not helpful, is it? 14th of January. No, it's not helpful at all. Can't possibly be right. That this can't. Let's just look at some of the chart and see if this. Oh, it's out of date. Sorry about that. I don't think I'm going to be able to get it. I don't really know if you can. I don't know. Maybe not. Anyway, I think that's enough. Anyway, I'm not sure if the wind shear is going to decrease or not. But if it does, we seem to have a good chance of some tropical developments. I mean, again, really kind of poor timing given the migrant situation at the moment. Really not what you'd want. but it'll still be interesting to watch the storm develop. Although, of course, I really hope it doesn't cause too many problems. It's not. But anyway, let's see if we get a nice I-type future developing. So anyway, thanks everyone for watching, and thanks for subscribing. I did my 400 subscriber video as a cyclone comparison, so check that out. Please rate, share, comment. If people share this video, it'd be appreciated, because again, this is as much as a question as it is me. I mean, I'm giving out the information that I know. This is my knowledge that I'm giving out. I don't really know the answer to this question. Could a hurricane hit Italy or France? I don't know. I'm not sure. I'm not sure if this has the potential. So if people could share it to people that might better understand this topic than I do, really useful. So those sorts of comments would be really appreciated. Thanks everyone for watching.